A very good afternoon to you all. We are into the second day of the 5-day STTP. Ladies and gentlemen, I am so pleased to introduce before you our resource person for today's session, Dr. Niraj Gupta. Dr. Gupta is currently serving as an assistant professor in the Department of Electrical Engineering, NIT Srinagar. After completing his BE in Electrical Engineering from Jammu University, he pursued his ME in Power System and Electric Drives from Thapar University. He then did his Ph.D. in Power System from IIT Roorkee. A prolific contributor in the field of electrical power system, renewable energy systems through his works in probabilistic quantification of power, various national and international journals of review, like Elsevier, IEEE, American Institute of Physics. Two books on artificial intelligence and fuzzy logic in power system stability, published under Lambert, also been a referee to IEEE journals, IET conferences, editorial board members to a few international journals, and is also been invited more often as a resource person by various institutes of national importance. Without further ado, please join me in welcoming Dr. Niraj Gupta. Sir, please, the platform is all yours.
Thank you very much. So, I'm Dr. Niraj Gupta. So, I'm delighted that you invited me for this session. So, definitely, I think that the students and the participants will benefit from this course. Actually, I will start with the basics of the MATLAB, and along with that, I will start with the hands-on practice. So those people who are having the MATLAB on the laptop, they will definitely open it so that hands-on practice can be done along with the lecture. So can we start?
Yes, sir. Yes, sure.
Okay. So, are you getting it?
Yes, sir, it has come in.
Hello.
It's visible. It's visible, sir.
Yeah. Now this is also visible, MATLAB.
MATLAB is not visible, sir. Here it is perhaps the PPT.
Okay, I will. Now it's very visible. Hello. Hello.
Yes, sir.
Now
it's coming, but
now it's MATLAB
is showing your presenting to everyone.
Now it's MATLAB is visible or not?
Yes, sir. Yes, it has come.
Okay.
Yes, sir. It is MATLAB.
Now today we'll start with the basics of MATLAB programming. We will start with the MATLAB and then we will discuss something about the programming. Now first, what is the MATLAB that you already know? That is, it was initially developed by lecturer in 1970 to help the students learn linear algebra. It was later marketed and further developed under the MathWorks. It is actually a software package which can be used to perform analysis and solve the mathematical and engineering problems. it can solve the complex numeric and symbolic problems in a fraction of seconds as compared to other languages which are available to us. And it has the excellent programming features like hello. So, are you getting me?
Yes, sir.
Hello.
Yes, sir. Yes, sir.
Yes.
Yes, sir. We are.
So we'll start with the MATLAB, the basic structure of the MATLAB. You have some of you already know about the different things in the MATLAB. Like you have the command history, command window, and the workspace. So when we open the MATLAB, are you getting the MATLAB here in my window in my computer? Are you seeing it? Hello. Hello.
Yes, sir. Yes.
Yeah.
Yes, sir. It's
It's visible. So when you open the MATLAB, you see the different type of windows which appear in the MATLAB. First, we have the command window, and then we have the workspace here, and the command history. So command window is the type of the window you can type anything in that and get the result in that. Let us suppose that you have a equals to 2, and then b equals to 3, and c equals to a plus b. So it is the window which is used for that very purpose. It is a memoryless window. It is not anything is not stored in that particular window. So it is a command window. So whatever the result you compile, it will come in the command window. And then you have the command history. Whatever you have done in whatever command you have typed here, it is stored in the command history. You can directly get the you can directly by clicking that you can get directly got whatever you have typed here. And workspace here, the variables are stored, different variables are stored in the workspace, and these are temporary variables. Once you close the MATLAB, it will not be there. So these are the different kind of windows which appear when you open the MATLAB. And now, like this one, that is, we have the command window, we have the workspace, and we have the command history. And now there are some basic commands which are used in the MATLAB. Like if you see, we have INF. It stands for infinity, NA, and it is not a number. Like CLC. CLC is often used to clear the command window. Like when suppose we have the command window and we use here CLC. So everything is cleared in the command window. So CLC is used whenever you are starting the MATLAB program. You first start with the CLC. CLC means that everything in the window got cleared. However, the variables will remain. Like if you see, we have used the CLC command, and in this case, you see in the workspace we have A, B, and C. They are still there. And one more command that you will use is the clear all. When you use the clear all the things in the workspace get cleared and nothing is left. So make sure that whenever you start a program, writing a program, you should start with the CLC. CLC will clear all the variables in the command window, but it will not delete. And second command that will you must use is the clear all. Clear all will clear all the variables in the this in the workspace. That is, nothing is, no variables left. Otherwise, sometimes let us suppose that we use something in the command window, and without clear all we are using that variable within some program. Let us suppose we have used a equals to 2, and within the program we have also used a equals to 2. So sometimes the overlapping will occur. So to prevent that, in that very case, first you will use CLC, and after that you will use clear all in the whenever you are writing a program. Now, second one is the close all. Close all means that all the figures in this case are closed. So it close all the figures. Now there are inbuilt mathematical functions also in the MATLAB. Like here we have the square root of x. Simply yeah, we can do here in this command window sqrt. We want the square root of 2, so we can write that square root of this. Second, we have the exponential, then we have the cos of x, sine of x, and sum of x. Sum of x means that let us suppose that we have a vector and having 5 values in that, and if we want to sum that, let us suppose that a is a vector and 5 values are there in that, and we want the sum of that, and simply we got the sum. So these type of commands are available in the MATLAB. Then it is one is a line space. It generates the row of under linearly equally spaced points. Then you have the determinant of A. Let us suppose that we have this some matrix is there, and 1, 2, 3. I will show you that how it can be entered. Matrix can be entered in next slide. That is, let us suppose that we have one matrix, and the name of the matrix is A, and you want to find the determinant of that particular matrix. So simply you can use determinant of this A. So many commands are there in this MATLAB. So then we have the diagonal of A. You get the diagonal elements of A. Then sometimes it is required that some identity matrix is required. So for that we use the I of n. That command is used. Sometimes, since in the MATLAB everything stores in the form of the vectors. So first you have to initialize something in that. Suppose you want to initialize a matrix of 2 by 2. So for initialization purposes, it should be a matrix of 0. So for that command should be used, that is zeros 2 into 2. It makes a vector of 2 into 2, but all zeros in that. Then you have the 1. Sometimes it is required in the programming. Then we have the length of some vector. Now let us suppose that we have a vector. We take the A vector. Let us suppose A is equals to, let us suppose that A equals to 1, 2, and 3, and we want to find out that how many elements are there in the A. So for that we are using the command length. So length of A equals to 3. So it has the 3 elements. And second, we are using the size. Size gives that what is the size of the matrix. That is, it has 1 row and 3 columns. So length and size are very important from the programming aspect. That is, whenever you are using the programming, length and size should be used. Next is the format in which it is displayed. There are different formats in which it can be displayed, like the format short. It is the fixed point 5-digit format, and it is actually a default format. Then format long, that is 15 digits. Then hexadecimal format, bank, that is dollars and cents, and rate, approximate ratio of small integers. Whatever is required, it is up to you. But generally 5-point digit is enough, so generally we are using the format short. Now workspace window. Whenever we are opening the workspace window, we want to know that what are the list of variables are there that you have entered. For that you must use the command who. That is who. In this case, we have this workspace. It is stored that a and answer is stored in that. So who tells us that what are the variables which are there. So while in the programming, starting the program, we must know that what are the variables which are defined already in the workspace program. Now also, if you want to clear any variable, simply like let us suppose that you want to clear a. So simply you put clear a, and you will say that a is not here. And if you want to clear other variable, then that variable is also gone. So any variable you want to clear, so you can write the command clear, and along with that a or any other variable you want to clear in the command window or the workspace. So clear all that we have discussed. Clear all means that all the things are cleared in the window, and we have the list of variable whatever they are in the program. Now let us suppose that clear all will delete all the variables from the workspace. However, when you exit the MATLAB, all the variables are lost. And if you use the command save for that, it will be saved in the command matlab.mat. And it will matlab.mat will save every variable which are in the command window. However, if you want to retrieve that, you can simply put the command load and that particular name that you have given, and simply you can retrieve that. Now command history. So this window lists the commands typed, whatever commands are typed so far. You can re-execute the command from this window, like we have also discussed, like these commands you can re-execute that. Let us suppose that you want to re-execute the command, so you can go to command history and then want to re-execute that, double click that, and you get that. Again you double click and you get that. And simply in this way you can also re-execute the command which are saved in the command history. And current directory is there, whatever things are stored in the folder. Like here we have the current folder, it is the current directory folder. Whatever the thing are stored or whatever we have here we are working, so that is the current directory. And help window is very important part of this MATLAB. Whenever you want anything, you simply go to the help window, or you type the help here. Let us suppose that you type help sum, then some commands will come, that what is the syntax of that and everything, whatever you want, so it will come. So help window is very important part. Whenever you see something is desired, you go to help window, you will go to MATLAB Central, you will directly connect to MATLAB site. They will give the solution to you, whatever is required. Every solution is provided to you, whatever is required. Now, as we have discussed the variables and the matrices, so all the variables are stored in the matrices. You see that in this case all the variables are stored in the MATLAB matrices. Let us take an example, like a equals to 4. So a is stored in the form of matrix. Like you see here, its size is 1 into 1. So this A is stored in the form of the matrix. Secondly, let us suppose that we want to store something that is 2, 3, and 4. So it is also stored. It is a 1 row and 3 columns, and everything in the MATLAB is actually stored in the form of the matrix, and it is a matrix laboratory, so everything works accordingly. And the second thing is that they are case sensitive. It means that if you have used the uppercase for that, you can use the lowercase for some other thing. However, you cannot have that if you save something in uppercase and you can get from the lowercase. So it must start with the letter, and the variables are stored in the workspace. Now, how to assign the values to a vector. Now come to the vectors. Now let us suppose that we have we want to input, that is A equals to 1, 1, 2, and 3. So it will give a matrix of 1 row and 3 columns. It will give a matrix of 1 row and 3 columns. Now let us suppose that you want a matrix of this is a row matrix and you want the column matrix. For that, let us suppose that B is equals to 4, then you use the semicolon, then 5, then 6. So it means that B is a column matrix. So simply, if you have to put a space between the elements, it means that it's a row matrix, and if semicolon is there, then it is a column matrix. Now let us suppose that you want a 3 into 3 matrix. So simply for a 3 into 3 matrix, let us suppose that you want 3 into 3 matrix. So simply you write 1, 2, 3, that is first row. Then after that, semicolon. After semicolon, second row will start, that is 4, 5, 6. So second row will start, then semicolon again, then third row will start, that is 7, 8, and 9. So simply 1, 2, 3, it is the first row, 4, 5, 6 is the second row, and 7, 8, 9 is the third row. And this semicolon represents that we have moved to the next column. And then we iterate, so we get the matrix 3 into 3 matrix. So this is how we can do that. Now let us suppose that in some case we have not put the space here. Let us suppose that we have not put the space after 2 and 3. So I think there should be error, because 2 elements are in the first row, 3 elements are in the second row, and 3 elements are in the third row. So so for that, I think it must be clear to you that how you have the matrix in this MATLAB. One more thing I want to clear, like let us suppose that we have a vector, that is A, 1, 2, 3, 4, 5, 6, and 7, 8, and 9 elements are there. Now we want to suppress the values of this. We don't want the values to be displayed on the command window. Sometimes we have a program which runs a large number of codes, and sometimes it is decided that everything is must not be displayed, only the results must be displayed. So for that purpose, we will use here after that we will use the semicolon. After using the semicolon, it will not come. That will not come like A equals to this, because it will be suppressed, like we have used here this one, and then we have used semicolon, it will be suppressed. However, when you want the result, you can definitely get the result in that. So this is how you can input the vectors in MATLAB. and then you can assign the values to the vectors in the MATLAB. So and this is how we have done for the vectors and the matrices. Now one more point is that let us suppose that we have a vector A. It is already displayed, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So making it easy, let us suppose that we take a very simple matrix A as 1, 1, 1, 2, 2, 2, 3, 3, and 3. A very simple matrix. So now what is required, that let us suppose that you want to replace the any element in that. Actually it represents A11, then this one represents A12, this one represents A13. And sometimes in a programming it is desired that the elements must be replaced. Let us suppose that we want to replace this 1, 1 element, and instead of the 1, 1 we should have some value. Let us suppose we want the value of 0. So simply what we do, A1, 1, it means that first row, first column is equals to 0. It means that in that thing the A11 is replaced by 0. So finally we are getting the A as 0, 1, 1. That is, here we have replaced it. Now one more point is there. Sometimes it is desired that we don't want any row or any column. Let us suppose that any row is not required in that. Then what we do? Before going that, we will here discuss that how we get the row and the columns. This is a matrix, and what we want. And sometimes in a programming, you want that on one row, first row, second row, or the third row, or first column, second column, or third column is displayed. So for that very purpose, what you do, this is A1, that is first row and this column. It means that A1 comma colon, it represents this first row, that is first row, and then we have the colon. It means that the first row is displayed here, and if we interchange it, that is, instead of this 1 comma colon, we will use we will use colon comma 1, then we will get first column, that is 1, 2, and 3. So it is very important part of the programming. That is, sometimes it is required that only first column or second column is required, or you want to fill only first or second column. So definitely that thing will help you. So this is how you can do that. So again, come to this. So we have this. Now suppose we want to delete any column, row. Let us suppose that we want to delete first row. So what we do, first row, whole of the first row, and we used this one, 2 brackets, and then finally we are getting this 2, 2, 2, and 3, 3, 3, and first row is deleted. Suppose you want to delete the second row, you can do simply like that, and you want to delete the third row, simply you can use like that. Sometimes it is desired in the programming also. Now here whatever we have discussed here, now come to the matrices, that is different matrix operations, like creating a submatrix, and how do you assess the elements which are in the matrix, that we have already discussed. That is how many elements are required here, and which row or which column is this required. So we have already discussed here. Now some of the special variables are there in the MATLAB. Like you will see that whenever you want you want some that is a symbol of the pi, you simply write pi 3.1416. Now in MATLAB, whenever you start the loop, you start with the I or j, but initially you must know that what it stands for. So I stands for 0 plus 1 into I, that is imaginary term. Similar is the thing with the j. That is I and j in this case are imaginary terms. So I and j are imaginary terms, that is root of -1 in this case. Now there are certain matrix operations in the which are available in the MATLAB, like you have the addition, you have the subtraction, then multiplication, element-wise multiplication, then power, element-wise power. We can discuss everything here. Now these are some of the relational operators in the MATLAB. Like we have the equal to here, that not equal to, that is we are having here, which are used in the programming. Greater than or equal to. Then we have the less than, then less than or equal to, and then we have the logical operators, logical and, logical or logical not. Now come to this matrix operations. Now let us suppose that we have a matrix. We will take the matrix that we have discussed, like this one. So we want to add something. Let's suppose we want to add some scalar in that, a plus 3. So we are getting that. Simply we want to do the scalar addition and subtraction in that. We can simply do that in the matrix operations. Then multiply and the divide. We have the a, let us suppose, then we want to multiply a with 3, and you can simply do that, and you want to divide a by 3, that is the scalar operations in the MATLAB. So you can simply do like that. Now come to this operations. Let us suppose that you have a matrix A. You have a matrix A. Let us suppose whatever matrix we have taken, we will take here matrix A, and you want that every element of the matrix must be multiplied by 2. Let us suppose some value. Every element must be multiplied by 2. So for that, what you do, you will, every element is multiplied by 2, then simply you can use the command dot multiplication of 2. So multiplication of 2 and dot multiplication of, in this case, is same. Here we have seen in this case, these are both same, because when we multiply it with that, so there is no difference in that. However, let us suppose that you want some other operation on the matrix A. Let us suppose that you want some other operation on the matrix A, that is A raised to power 2, that is A square. So in this case, the A square is whatever we can calculate the square, that is A into A. There are different that is methods to calculate that. However, in a programming, sometimes it is desired that every element of this matrix must be multiplied by, there must be squared, that is dot 2. So whenever you want that every element of this is multiplied, so you use dot in that. That is, it means that since this MATLAB works, everything is stored in the matrix. So you have to work in the matrix. If you are looping, you have to think in that way only. Sometimes it is desired that all the elements of the matrix must be scared, but not the whole of the matrix. So for that very purpose, you can use this dot along with that, so that all the elements of the matrix must be squared, and this is not equals to this. So that thing we must be clear that how we can do the programming in that. Now next, matrix operations. That is, let us suppose that we have the two matrices. Like, let us suppose that we have matrix A, and then we have a matrix B. That is, B equals to, we can take some simple matrix. It is 5, 4, 6. Then we have 7, 6, 5, and then 9, 5, 4. So we can take the two matrices A and B. Now, A is also 3 into 3 and B is also 3 into 3. Now, let us suppose that you multiply A into B. You got some value. Now, sometimes it is desired that instead of multiplying these two matrices, you can multiply the individual elements which are at their place. That is, A11 is multiplied by B11, A22 multiplied by B22, like that. So for that, you have to use dot here. So whenever you are using dot here, it means that the elements or first element of this A is multiplied by this, then this second element is multiplied by this B, then third element. So it is very much required whenever you are doing the MATLAB programming, because everything is in the form of the matrix. Now, second point is that sometimes sometimes we have the A vector, some vector is there A, and then second vector is B, and B vector is actually the vector which is actually the power of that A elements, all the power of that elements. So for that also you will use that dot, like A dot power of B. It means that every element of A, every element of the A has the power of B. That is, 1 1 has the power of B 1 1. So simply you can get the result. However, if you want to calculate that A raised to power B, you can calculate. You cannot calculate because A is a vector and B is also a vector, and you cannot have that a vector has a power of vector. It is not possible. So this is also one important point you have to take into consideration. So then you have matrix operations, like sometimes you want the division of some matrices, you can simply do like that. And then you have the error, whatever I have discussed, that you cannot do A raised to power B. You cannot do that. However, if you want that B matrix is the power of the A matrix, all the matrices of B are the power of the A matrices, then you can simply do that. That is, 1 power of 1 is 1, then 2 power of 2 is 1, like that. Now, now come to the math operations. Now we will discuss some math operation and then we can discuss the programming part.
Your voice is breaking sometimes.
Hello? Hello?
Yes, sir, your voice is sometimes breaking. Yeah, hello.
Are you getting me?
Yes, sir. Your audio is sometimes breaking. Rest is okay, sir. Rest is okay. Rest is okay, sir.
Everything is okay, na?
Yes, sir. Yes, sir.
Okay. Okay.
Your voice was sometimes breaking, actually, sir. Otherwise, everything is okay.
Now come to the math operations. So in math operations in MATLAB, you have the symbolic math operations. Let us suppose that you want to do some differentiation in MATLAB. So for that very purpose, what we do, you write the command that is differentiation of sim SYM. SYM represents the symbolic math. So since it represents that X is a symbol, otherwise instead of that we cannot do that if we are not using here sim. We cannot do that because MATLAB cannot recognize it as a symbol. Here MATLAB recognizes X as a symbol. So we want the differentiation of X square. So we use the sim here because it is a symbolic math. So when you enter it, so we are getting 2x. So in this way, we can do the symbolic operations also in the MATLAB. Let us suppose that we have the integration here. So simply integration sim 2 into x within the commas. So it means that we are integrating 2x. However, it is symbolic. So it is x square. And again, one more operation. It is the of definite integration. Now let us suppose that we have a definite integral which ranges from 1 to 2. So we simply get the answer 3. Now sometimes we want to solve the algebraic equations in the MATLAB. So suppose we have the two algebraic equations, that is x square plus xy plus y equals to 3. Then x square minus 4x plus 3 equals to 0. So we want to solve these two algebraic equations in the MATLAB. Now the syntax for this is xy, that is we have the variable x, then also we have the variable y in that very case. So xy equals to solve. We use the command solve for that very purpose, and then finally when it solves it, we got the value of x and y. Symbolic math is very important part of the MATLAB. So it gives us that how the things will work out. That is how we solve the equation in the MATLAB. One more point. Let us suppose that we have this equation in the MATLAB. We want to write this equation in the MATLAB. So this one. So it will give the error in that, because in that very case we have not specified whether these are the and some data elements or some symbols. First we have to specify it. That is, we have to use the command SYM, that is F A X, then B X and C. So it means that we have defined that these are the symbols. We have to use sims command. It is symbol, and finally we can write this equation, and this equation is displayed in mathematics form. That is a into x square plus b into x plus c. So before going for any mathematics operation, you have to define all the parameters, that these parameters are the symbols. Then MATLAB took them as in the symbolic format. Now some of other operations in the MATLAB, like you have this. It is symbolic math is very important toolbox for the engineers also, for the researchers, because they can solve their equations also in that. Like we have expand x plus y raised to power 2. We have not defined the sims from the sims point of view. We have to define first sims xy, and then the expansion will come. That is CLC. We will clear it. Then we define sims x, y. Then we write the expansion, that is expansion of x plus y square, how much it comes. Okay. Now, similarly, we have expansion of sine of x plus y. That is sine of x plus y expand. Here we have used the command expand. Previously, for solving the algebraic equation, we have used the command solve. So here we have used the command expand, that is, it will expand it. Then one more command in simple in mathematics is simplify. That is, we can use it. We can have this equation, that is 6 into sine of x square plus cos of x square. We simplify it. We use the command simplify. So what the simplify will do? Simplify will, it will simplify it and give the answer as 6. However, MATLAB is very user friendly. It means that if something you type wrong, indefinitely it will correct you out. Now, here also you can also find that what are the variables in that. Let us suppose that here we have a function f equal to x raised to power n and g equal to sine of a into t plus b. So what you want, you want that how many, that is what symbolic variables are available in f. So you can simply put find sim f, you can simply get n into x, and find sim g, you can simply get a, b, and t. So so different kind of operations you can do in the symbolic mathematics. It is a very important part of the mathematics, and more about that, these are the basic operations that I discussed, and more about that you can see in the help file also. However, whatever like I told you also, the whatever is desired you find in the MATLAB. Don't go of learning everything in MATLAB, because MATLAB is very vast. Whatever is required for your understanding, you can learn that. Now, next are the M files in the MATLAB. So this whatever we have discussed is related to this command window. Whatever we write and everything is stored in this workspace for some time. When we clear it, and the whole of the workspace is cleared along with that. However, whenever you want to write something or write some code in the MATLAB, you will start with the script file. That is, script file is also known as the M file, because these are stored with the extension of .m. That is, you will go here, and after that, new script, the file will come. This is actually the script file. Here you have to write the program so that it can be saved. Here you can debug the program, you can correct the program. Whatever you have to do in this script file. So in the script file, before starting writing any program, you must clear that two commands you have to use every time. That is CLC and clear all. It means that CLC means that the everything in the command window is cleared, and clear all means that everything in the this workspace is erased. Nothing is left, so that your program will work smoothly. You need not to have any errors in that. Sometimes very silly errors occur in the MATLAB, and you feel that my program is not working. But sometimes this thing comes into being because these you have written some x, and x is also in the loop, and then some overlapping will occur. Now, so these are the M files. These are actually the script. These are these are known as the script files also. These are collection of the commands executed in sequence. and when called, saved with the extension .m. Second is the function. These are the user defined commands, normally has input and output, and these are also saved with the extension of m. We will discuss both. Now here, I have discussed this m file. We created this file, m file, and then after that, this we have to save this file. See, so we have to save somewhere in the somewhere here. Let us suppose that we save it as STCC. So this is saved here. So wherever you want to save, you can save it. So this is the script file, and simply you can run that script file also by from the command window also. Like let us suppose that instead of going in programming, let us suppose that a equals to 2 and b equals to c and c equals to a plus b, and we want uh, this file. We want to run this file, so the name is stcc. So the name of the file is stcc. So it will run and it will give the result. So this is one of the way to run the program. And the second way to run that, you can go, from the script window, you can use the run command. Here you can click run and it will run the program. Now, now we will discuss about the loops. We will discuss the small problems, because when you understand the small problems, you can make the big programs. That is what we do in the research also. We start with a very small thing, like in a power system also we start with a 2-bus system and write it with hand, and then after that we will do the programming of that. So that is what it is required. Now we will start with the for loop. So what is the syntax of the for loop? First, what the for loop do? It executes the group of statements a fixed number of times. Now we can write here a program. Let us suppose that we want to write a program of addition of the numbers. Okay. So first we take the addition of numbers from 1 to 5. Then we can generalize it. So for I equals to, one more point I want to discuss before going to that. This one, this column and 5 represents that we have values from 1 to 5 with an increment of 1. That is, values of 1 to 5 with an increment of 1. Now, suppose you want the values with an increment of 2. So simply you put 2 here. Within 1 and 5, you put 2 with the this column. Then simply you will get 1, 3, and 5. So it is very important part of programming. That is, you will use 1 to 5. It means that our loop is from 1 to 5. So first we will start with the CLC, clear all. Then for I equals to 1 is to 5. It means that loop will start from 1 and up to 5. That is, I varies from
Sir, hello, sir.
So, are you getting me?
Yes, sir.
Hello?
Yes, sir.
Everything is fine in is it working fine?
Yeah, it got paused for a while, but now it's perhaps coming. Yeah, it's coming.
Okay,
Let's
okay.
come.
Okay, thank you. So we start with the for loop, that is for I equals to 1 is to 5. It means that I will move from 1 to 5. And we have the end, because whenever we are using the loop, we use the end along with that. Sometimes there is error, there is some error in program that you have not used enough number of ends in that. So make sure that the number of ends, the number of loops which starts and ends should be there in that. So what you want, we want to add the uh, number from 1 to 5. So the logic would be x equals to x plus I. So, and we have to initialize that also. That is, we have first as x equals to 0, then we have a loop from I equals to 1 is to 5, that is loop will move from 1 to 5. Then we have this logic that every time x is added with I, and I varies from 1 to 5. So this is the loop. So now what we do, this is the for loop, simple for loop. What we do, we run the program. We here run the program, and finally we are getting the value of x as 15. So the value of x as 15, which is the required. Now instead of 5, what we do, we will use 10 here. That is, we want to add the values of 1 to 10. So simply we get the value of x as 25. Now it is we run the loop and then we have to see the things. So instead of that, we can use the display command also. That is, display command is used for that very purpose. That is, display the sum is. The characters are actually placed here, and then again we have display x. So this is the syntax how we can display. So we are getting the sum is 55. So whenever you want to display and you want to write something, so you can use the command disp, and along with that the sum is, that is characters, commas you can use, and after that you can use the display, and whatever you want to display you can use it in the square brackets. These characters are displayed like that, and the things variables are displayed like that. So this is how you can display the things. Now this is a simple program of adding 1 to 10. Now we want to generalize this program. It is a for loop program. We want to generalize this. We want that everything we want as an input. That is, the MATLAB will give the control to the keyboard. So for that very purpose, we will use the command input. That is, n is equals to input so the values to be added. It means that what we have done, we have used the command input. N equals to input. So n will take the value from the keyboard. Input means that value should be given from the keyboard, and it is displayed the values to be added. Okay. So this input command will give the control to the keyboard, and then what we do, we simply, instead of using 10 here, we simply use n here. So this n we will get from keyboard, and then finally that n will move, and as a result we are getting the result. Like, let us suppose that we want to add 3. The sum is 6. Then suppose we want 5. The sum is 15. Then suppose we want 10. And the sum is 55. So in this way, we have used the for loop for finding the sum of the n number of digits. N can be anything. Let us suppose that we take the n as 5000. So the sum would be like that. So in this way, what we have done, we have found the sum of the n number of digits, and also we have generalized it so that we can give the control to the keyboard. The keyboard will do, and we act as an user interface so that we can give the command to it and it will work accordingly. So input command is very important part. So what we have done in this case? In this case, first we started with the CLC and clear all, which are important. Then we have used the command x equals to 0, that is initialized it. Then we have started with the loop, for loop, which is the syntax of the for loop is for I equals to 1 is to n and end. And within that, we have used the logic, that is logic is x equals to x into I. And we want to display it, then we use the command disp. The sum is, this is for the characters, and then you display the variable like that within the square bracket. And to input that, we can simply use the command input. Input simply gives the command to the keyboard in that very case. Now, this is the for loop. It executes a group of statements a fixed number of times. Whenever we are doing our programming or anything, we are using the for loop. Every time we are using the for loop. So for loop is very important. Second is the while loop. So while loop is actually it is a group of statements. It executes the statement for an infinite number of times until that logic is satisfied. Like here we see x is equals to 7, and while the syntax of the while loop is while and then end, and this is the condition unless and until the x is greater than or equals to 0, x is equals to x minus 2 and end. So we can compile it also in our script file, that is so this is the syntax while this is the condition, what condition must be satisfied? This is x equals to x minus 2. This is whatever is required, that if that condition is satisfied, then this is required in our case, and this is end. So like the for loop, we have the while loop start, then we have the this condition, and then we have the end. And when we run the program, I think this for loop program is working. So x, instead of this, we use y here. So we want the value of y is equals to -1. So this condition is satisfied, and result we are getting as -1. So this is also the conditional loop. Whenever some condition is satisfied, the while loop will work, and when the condition will not be satisfied, then it will not work. Now, next is the if statements. If statements are very important statements, and if you want to suppose you want something inserted in your code, you can use the if statement. Now the syntax for the if statement is, that is, we have the if, then we have whatever is required, then else if, or this one, and then else. So what we do, we will insert the if statement in our for loop. Now let us suppose that we have this for loop. What we do for a while loop, what we do, we will comment it. One more thing I will discuss with you, that whenever we comment something, that is, we use the sign of percentage, it means that it will not move in a program, that is, it will not act as a variable. It only acts whenever you want to write something or some statements. So simply you can use this percentage for that very purpose. However, it will not be executed. So let us suppose that we have the for loop 1 to n, and suppose if you want some kind of statement inserted within that. Now if x is equals to 3, if x equals to 3, and let us suppose that you want to display something that is, the value of x is 3. Okay, so it means that if that thing is satisfied, then in the command window it is displayed that the value of x is 3. Now we will comment this. We don't want to run this while loop, so we will comment this in here comment section. It will comment it, and it will not be executed. And finally, the value of x is 3. It will come. That is, it will come at the third iteration. I will tell you that how, in which iteration it is coming. Like here, we will not use the semicolon, and then we have 5 after the, and that when x is 3, the value of x is 3. It will be displayed. So this gives this if else or else if executes the group of statements based on some logical conditions. So it will execute the group of statements based on some logical conditions. Now third one is the switch statement. Switch statement is actually the syntax for the switch is switch. Then we have the case 1. Case 1 is satisfied, then you display this. Then if the case 2 is satisfied, then it is displayed. This one is displayed, and otherwise this one is displayed. So it executes the different group of statements depending upon the value of some logical conditions. So it works like that. It is like if you do the simulation of 118 in power system simulation, 118 bus system or 57 or 30 bus system. So you can use the switch statements. That is, if you enter 118, then the 118, the bus data and line data will be taken. Now here we have a small example of this switch statement. Like we input the number from the keyboard. Let us suppose that we input the number from the keyboard. Let us take an example. We will take some new file, script file, and then we will save it as now. Here we have this is the syntax of the switch command. First, switch, and n is actually the condition. Case, this one, that is if the value of n is -1. First, what we do, we have used the input command here in this case. So if we want to put any value here, that is n, it is the command will be given to the keyboard, and keyboard will we will give any command to the to this MATLAB. Then it will see if the value of the n is -1, then it will display the -1. If the value of the n is 0, it will display the value as 0. If the value is 1, then it will display the positive 1. Otherwise, it will display other value. So in this way, it is the simple syntax of the switch command, that is switch loop, that is this switch and then end, and in between we have the case and otherwise. So let's run that. Enter the number. Let us suppose that we enter 0. So it comes 0. That is, when we enter the 0, so it will display the value as 0. Before going that, we will start with the CLC so that everything is cleared in the command window. Now again we will run it, and if it will ask enter the number. So suppose we put the 4. So other value, because we have defined what we have defined. We have defined for -1, we have defined for 0, we have defined for 1, and for 4 we have not defined, so it will give the other value. So when we are doing the programming, suppose for 30 bus system, 14 bus system, and 118 bus system, it is very important that which bus system we want to go. So switch command is used. It is an application of switch command. Here we have applied the switch command. One more example of the switch statement is this one. That is, let us suppose that we have some X, a matrix X is there. So we will we have, and plot type is pi3. So switch plot type. If we write the pi3, then under pi3 we have this pie chart, and in that very case the bar is displayed for these values, that is 12, 64 and 24. Let's see that when we run the program, so this pie chart will come. That is, since we have defined pi3, and pi3 in this case is pie chart. So instead of the pi3, let us suppose that we are using the bar. So when we are using the bar, in that very case, the bars will come. So this is how the switch command will it works, and It is also it is very much used in the programming part also. Now, come to some of the these statements. Sometimes what we do, sometimes we are doing the programming and the program will run again. It will run, and we want to break the program at a particular point of time. So it's for that very purpose we are using the break command. So let us suppose that we come to this one for a for loop that we have discussed here. Now we will use the break command here. Now let us suppose that we want to break that command at if I equals to 10, then break and end. It means when the iteration is 10, then the loop will break. So let's run it. Suppose we have, so the loop will be broken when the iteration is 10. So at the 10th iteration, the loop is broken. It means that the I is equals to 10. So in that very case, the loop is broken. So sometimes it is decided that the program is running, so we want to break that program at a particular point. So simply we use the break commands. Let us suppose that we have 1000, and then again we give the value of the n as 1000, but at 10 the loop will break. So break command is also used in this programming. Second is the continue. Now the continue, it actually passes control to the next iteration. It means that that iteration will not be done. Let us suppose what we do. We take a small example, that is I equals to 5 continue. It means continue means when we are using the continue, that it will not, that iteration will not be evaluated, and it will go to next iteration without evaluating that. However, the break statement will break the loop, and the continue statement will skip that the loop. That iteration is skipped. In this case, we will see, that is, we give 5. So since the sum of 1 to 15 is sum of 1 to 5 is 15, however the 5 will not be evaluated, since at that very time we use the command continue, and continue means that that iteration will not be continued. So it is very important part, and the return is actually simple to, it is similar to this continue. So it causes the execution to return as the invoking function. After execution, it will move to the invoking function. So this is some of the things that we have discussed. That is CLC, clear all. Then we have x equals to 0. So this is the for state. This is the for loop for 1 is to 5. That is adding the number from 1 to 5, and this is the while loop. So here we have used the break command. In that very case, we want to, after the third iteration, we want to break the things. We want to this break we want to break the loop. So after third iteration, the loop is broken. That is, if I equals to 3, then break. So loop will be broken. It will not move. Now then we have the continue statements that we have already discussed. That is, that iteration will be skipped in that very case. Now this is all about the continue and the return. Now there is a small example that has been taken. Like we have to write a MATLAB program to compute the summation of 1 divided by I square, and I varies from 1 to 10. So there are two different ways to do it. We start with 1 to 100, and then we start with the from 100 to 1. So similar to whatever we have discussed in the for loop, that is, we start with the forward sum equals to 0, and I equals to 1 is to 10. Then forward sum equal to forward sum plus I divided by I square. That is the logic. And in the backward summation, what we do, we start with from the 10, that it varies from 10 to 1 with minus 1, decrement of minus 1, and we have used the loop in that very case. So this is one example. Now, instead of going to write the program that is a large number of lines for that program, it is better to write in the form of function. That is, to write any program in the form of the function, because function actually in the function, the plus point of the function is that you cannot have the variables which are overlapping. Variables will not overlap, and you have different files, and small number of the lines of the code can give you output, and if any error will come, then it will give that where the error is, it will show you that where the error is, and you have to work in that function block only. So it is actually commands, functions, and intermediate variables that you want only input and you want the output in case of function. Now the syntax of the function is, we have the function output equals to function name and input. So like as you see in the power system, we have the output as the voltage and the angle. So what we do, you write as a function v del equals to load flow, that is sum L. So in this way, what you do, you can specify only PL and QL, and finally with this file name only you can get the value of V and del. So we can discuss the function here. So there are something about function, that is users can write function which can be called from the command line, and in MATLAB functions closely resemble scripts and can be written in MATLAB editor. This is how we can discuss the main part of the function in that. Now start with the CLC and clear R. So then after that small program that we have started, that I equals to 1 is to 5, that is a summation of 1 to 5. Then we have inserted one if loop in that is, if f(x) is equals to 15, then display the sum is 15. Else if x is greater than 5, then it will display x is greater than 5, else display x is less than 5. And then we have used the switch loop here also, and that is a switch x. So whatever the value of the x, if the value of the x is less than 5, then it will display the switch x is less than 5. If is equals to 6, if it is 6, then it will be greater than 5, like that. So what we do, instead of writing, we have this program. So instead of writing this program and then debugging it, we simply write a function. So function sum equals to sum of is the file in which it is saved. It is the file in which it is saved. So what we do, we create a function let us suppose that we make one file, script file, we place here function script file. In the function, the input in this case is n. The input in this case is n, and the input in this case, the syntax is function sum equals to sum of. Sum of is actually the file name in which it is saved, and in this case the input is n and output that we are getting is sum. The output that we are getting is sum. So how you can run it? You can simply write in the command window or any other editor window, if you want that, of any other editor window, if you want to write that, you can simply, and that is a function sum equals to sum of n, and all the program is written in this form, and in this case sum we are getting as x. So x in this case is the output. So x in this case is the output. So sum is 15, and everything which is in that file is also displayed. So if we don't want anything in the file, we can skip that. We can skip that also. If we don't want anything, we can skip that thing, and finally, that is, we can comment it, and simply even getting sum of, it is not saved, I think. Sum of 5 is 15. You can put at your own end. Suppose you want 13, sum of 13, and here it is, value as n. You got the sum of 13, then you want the sum of 100, whatever you want. So the function will give the program of only one line. However, the files would be different, different functions would be there, and different files would exist. Now the last part that we discuss is the debugging, how to do the debugging. That is very important part of that. So what we do, suppose you want to run the program and some error is within the program. The error will come and you're not able to find the error in the program. So for that, the debugging is very important part. What you do, you take your arrow here and place your arrow here in this. So when you place your arrow here, a dot of red color will come. So a dot of red color will come. It means that you started your debugging here. Now what you do, you run. So the arrow will, when you run, the arrow will come here. The arrow is coming. Now you move to step. It will take one step. The program will take one step. It will move to second step. You will see in the window. Then the arrow is moving to the second step. Then the arrow is, then we have demanded that values are added 5. Okay. Then the arrow is moved to this part. Now again step, next step. If we go to if, since that thing is not satisfied, so it will not go to continue, it will go to end. Okay, and it will go to end like that. Again, second iteration, it will see the second iteration. The second iteration is not satisfied. Again, the I equals to 3, it is not satisfied. Within that, you can also see the values in the command window. That is, you want to see the values in the command window, you can put x is 6 here. So within that, you can also see the values. That is, this is the process in which what you do, you can go, you can move a small steps and see that how the loops and everything is moving. Okay, now this, and again I is 5, so it got out of the loop and it is here step, and then again it is displayed here. So this is very important part of that, this debugging process, very important part. Some of the other things in that is when you run it, suppose you have a very large program and you want to go within the program. That is, step is continue. Actually, continue means that the loop will continue. Sometimes you find the error and then you want the result. So you will use the continue. The loop will continue. It will not move within that. However, this step will give every step within the loop. And if you want to go within the loop, suppose you want to enter within the loop, you have a very large program, and if you want to enter the loop, and suppose you have a function, you want to enter the function, like whatever we have done here, like take the example of this function, that is sum of n. So here we can add here this one. So again we run it, step 5. Then again it is here, it is at this function. Then when you use step in, it stepped within the function, and when you use the command stepped out, it stepped out of the function. Again I will tell you, that is, put the dot here, then run it. After that step, after that again we have the step, it has gone to this input command, that is, we have put the input here, and it is here, it is at the point of the function, that is function that we have created, that is sum of function that we have created, and we want, in the debugging process, we want to enter within this function. So for entering the function, what we do, we will use this step in, that is, it will go within the function, and then again stepwise it will move within the function, and you can find that where your error is, you are able to find debug your program, and then if you want to get out of that, and sometimes you find that there is no error in the function, then definitely you can go out. So it is step out. So in this way you can do the debugging of your this program. So hello, I think hello.
Yes, sir. Yes, sir. Yes, sir.
So I think you understand that, or everything okay? Hello.
There are some questions raised by the participants, sir.
Okay.
The first question was placed by Arjun Dawn. He asked that, sir, what would be the command to know the length of a string?
Length of a string?
Yes, sir. The first question. What would be the command to know the length of a string?
actually we can go to help for that actually, because I'm not working on string. I'm not used that.
Okay, sir.
Yeah.
The second question was posed by Devan Sashi, and he asked there, are SYM and SYMS same?
Actually, when we are using SYMS, na?
Yes, sir.
Hello.
SYMS, yes, sir.
When we are defining for a particular variable, so we are using the SYM. Suppose we are using differentiation, and we are using SYM and X in that, so we use SYM command in that. However, if we want to specify first that what are the sims, so simply we are using SYMS command in that.
Okay. Okay. The third question is placed by Mohammad Azizuddin Ahmed, and he asked that, sir, what is the difference between display and print sys command?
Which one?
What is the difference between display and print sys command?
Display and
print sys, print SYS.
Print SYS.
Yes, sir.
Actually, that print sys I have not used, and I am not aware of that.
Oh, okay.
So
the last question.
Display.
Yeah. The last question.
Display in. Yes.
Yeah, yes, sir. Go on, sir, please.
What?
The last question is asked by Rahul Mandal. He asked, I want to put a range like I is equal to 2 to 5. How will I do that?
Okay. So range means what he wants to do?
I want to put a range like I is equal to 2 to 5. 2 till 5. How will I do that?
2 till 5.
I is equal to, yeah, 2 is to 5, perhaps that will be answer. Someone already answered that question.
Yeah, 2 is to 5. You can do like that, 2 is to 5.
Yes, sir.
That is, it ranges from 2 to 5. That is, starts from 2 and then ends 5.
Yes, sir. Some more questions have come up, sir.
Okay.
Sir, Hemant Kumar Meena asked that we can I do. I didn't get that question actually. If script file not execute function file, it is in the chat, sir. You can have a look at it at around 4:36 p.m. Sir, we can I do.
Okay. Okay. They have asked.
Yeah.
Okay.
I'm not getting the question. We can I do if script file not execute function file.
Actually,
so what we can I do?
Script file
not execute function file.
Actually, I'm not getting your voice.
Hello, sir.
Yeah. Now tell me.
Yeah, the last question is actually I'm also not getting the thing. What we can do if script file not execute function file?
If the script file not execute function file.
Yes, sir. Yes, that is the question.
Yeah, actually, I think maybe some error is within the function file. Nah? He has to. That's why I told him about the debugging part. Debugging is very important part.
Yes, right, sir.
He can do that, and accordingly it will work.
Okay.
And you can give my mail ID to the students if they want anything from me. I will give them. I will love to give them.
I was about to tell that actually, sir. We will be sharing your email ID to all the participants.
Yeah, share my mail ID.
In any case, they may have find some
no issues. They will ask me directly.
Right. So I
they will ask me. Actually, MATLAB is so vast, and we cannot have so much thing in a small amount of time.
Absolutely. So finally, we are really very grateful to Dr. Niraj Gupta sir, for having agreed to our request to be a resource person for this 5-day program in a very short notice and keeping some time apart
Okay,
for us out of his very busy schedule. We appreciate for everything you have taught us during today's session. It was really informative. And this will certainly inspire the engagement of the students, researchers, and faculty members from various institutions for the coming days as well. Thank you very much, sir. Uh, so,
okay. Thank you.
dear
Thanks.
participants, yes, sir. Dear participants, with this we come to an end of the session, and let's meet again tomorrow at 3 p.m. Till then, goodbye and take very good care of yourself. Thank you, sir.
Okay, thank you very much.
Thank you.
Thanks.